Hello everyone, this is Aditya, and today we are going to study Modulus function because I saw many comments related to Modulus function, so I thought to make a video on it. So let's study today Modulus function. But before that, please do like, share, subscribe my channel, and we support this video. Now let's start with the lecture. So first of all, let's see what do we mean by Modulus function. So it is defined like this. This is called mod x or modulus of x, and it is defined like this. It is x if x is greater than 0 and is 0 if x is equal to 0 and is negative x if x is less than 0. Yeah, now many will be confused that why I wrote this third condition. I could have clubbed it over here also or here also. But now see, then it becomes ambiguous because many students ask me that where to put equality sign, like over here greater than equal to or over here less than equal to. So to remove that ambiguity, I made another condition that it is 0 if x is equal to 0. Now what does it mean? Well, let's use this condition to understand it, right? So suppose modulus of 1, what it will be? Since x is greater than 0, right? So it will be equal to 1, correct? Okay. Now modulus of 0, well, if x is equal to 0, then it is equal to 0, correct? Okay. Now suppose modulus of negative 2. Now if x is less than 0, since negative is less than 0, right? Which means that it will be negative x, so it will be negative of negative 2, which is equal to 2, right? So from all these three conditions, you know that mod x is always greater than equal to 0. And basically mod x is basically giving the positive value of the quantity which is being given in input, right? So if you give negative 2, you got positive 2. If you give a positive quantity, it give a positive quantity. If you give 0, it will give 0, right? Correct? Yeah. So this is a basic meaning of modulus function, and there's some properties related to it. So let's discuss it also, right? Okay. So suppose if you have mod x is equal to a, right? And of course, a has to be greater than equal to 0, right? If a is negative, then no solution exists, right? Since mod x is always greater than equal to 0, right? Okay. Then in this case, we get x is equal to plus minus a, right? Fine, correct? Okay. And suppose if you have mod x is suppose greater than a, right? Okay. Then in this case, what you get is that x will be greater than a, right? This is the first condition. Of course, if x is greater than a, then in that case mod will be always greater than a, correct? Or x will be less than negative a, right? Why? Let's take an example to understand it. Suppose mod x is greater than 3, correct? Fine. Okay. So x greater than 3 will satisfy this, right? Okay. Or you can also take that x is less than negative 3. Why? Suppose take any number less than negative 3. Well, negative 3.5. So if you take mod of negative 3.5, it becomes 3.5, which is of course greater than 3, right? And if you want to prove it, it is very simple. So let's break it into cases, right? Case 1, let's assume the first case has x greater than equal to 0, right? Okay. I just clubbed 0, equality of 0 also here, right? So don't worry about it, okay? So this is our first case, I mean first condition also. Then mod x will open with a positive sign, so x greater than a, this is a condition which has to satisfied over here, and x has to be greater than 0, this has to be also satisfied. It means that x greater than a intersection x greater than equal to 0. Let's plot it first of all, okay? So it will look something like this. These are 0, right? This is 1, this is 2, this is 3, and so on. We are not drawing the negative axis because we are not worried about it. It won't affect anything, right? That's why. So greater than equal to x means something like this, right? This region, correct? Okay. And suppose a is somewhere over here. Let's assume it, okay? Then in that case, it will be an open circle and it will go like this, okay? Then this area will be this, right? So the common area will be this only. So it means that the common area is x greater than a, right? This is the first condition, okay? Now let's check for a negative value of x. Let's check for case 2 in which x is suppose less than 0. In that case, mod x will open like negative x, correct? So negative x greater than a, or means it implies that x is less than negative a, correct? And this is what I have written over here. And of course, when you take the intersection with this condition and this condition, you again end up getting this condition only. So that is why I wrote this. Okay, now understood that why it comes like this. Okay, and of course, if there's equality, you just put equality sign over here, right? Okay, so I'm not telling in different ways. So here we discussed equality and here we discussed inequality, right? Okay, now we have a triangle inequality that mod of x plus y less than equal to mod x plus mod y, correct? Fine. Okay, so I wrote this property, but how will you understand this? Well, and why is it inequality? Why can't we just distribute it like this and say that they both are equal? Well, there's a catch in this. Suppose x is equal to 2 and y is equal to 3, correct? Then mod of 2 plus 3 is equal to mod of 5, which is equal to 5, and mod of 2 plus mod of 3 is equal to 5. Okay, so they both are equal. Then why we are saying less than equal to? There's a catch. Instead of y, let's take, instead of 3, suppose let's take negative 3. Then mod of 2 minus 3 is mod of negative 1, which is equal to 1, right? But mod of 2 plus mod of negative 3 is still 5. And notice that this quantity is always less than this quantity, right? Why? Because notice that x and y can be negative or positive both, right? So their sum can be less than this. Why? Because they both are always positives, and sum of two positive quantities is always less than their difference, right? Correct? Understood? So that is why this quantity is always less than equal to this quantity. Okay, now when does equality holds? Remember this: if x into y is greater than equal to 0, right? Then in this case equality will hold. Why? Because if their product is greater than equal to 0 means they are positive, then it means that both x comma y are either positive or both are negative, right? They are either positive or they are both negative. Why? Because positive into positive is positive, and negative multiplied by negative is always positive, right? So it means that if they both are negative or they both are positive, in that case equality holds. This implies that x plus y mod is equal to mod x plus mod y, right? Why? Because if this is also negative and this is also negative, then it is basically addition of negative quantities, right? So of course they both will yield the same answer. But if xy is less than 0, and of course y included 0 over here, because if any of the term is 0, then also equality will hold, right? Suppose y is equal to 0, then mod x is equal to mod x. It is true, right? Then it implies that mod of x plus y is less than x plus mod y, correct? So it means that one is positive and one is negative, just like this case. One is positive, one is negative, and here one was positive and the one was also positive. So this was first condition, right? If you want to check, let's take x is equal to negative 2 and y is equal to negative 3. So mod of negative 2 negative 3 is equal to 5, and mod negative 2 plus mod negative 3 is equal to 5 again, right? And this condition is many times useful in our calculations. You will learn about it if you solve problems, right? So I would recommend you to solve problems also, right? Of course, problems are very important to get success in any exam, right? It is be it JEE, be it your any exam. Always calculations are really important. I mean, calculations and problem solving is a very important task which you have to do, plus mocks, right? You have to give mocks and everything, right? You must have been guided by your coaching or something else, some other means, right? So basically, problem solving is the key over here, right? The more you do problem solving, the more you will understand it, right? Now there's one more condition in this case. Let's take that also. Now suppose you have mod of x minus y, then how can you open it? Well, let's see it. Mod of x minus y can be opened like this. mod of x minus mod of y, correct? Fine, okay. Let me explain it. Suppose x is equal to 3 and y is equal to 2, correct? Fine, okay. Right, is it fine? Okay. So in this case, you will get mod of 3 minus 2 is less than equal to mod of, this is mod, this is also mod, this is mod 3 minus 2. So of course 1 is equal to 1. In this case it holds true, right? Or you can write like this also, right? But now assume, if suppose I write it like this, x is equal to 3 and y is equal to negative 2, then in this case this expression will become 3 minus 2, right? Why? Mod of 3 is 3 and mod of negative 2 is equal to 2, right? And why we take a mod? Since of course this difference can become negative also, right? Suppose if mod y is greater than mod x, so to make whole expression positive we put a mod sign over here, right? Okay, this is 3 minus minus 2, which becomes 3 plus 2, that is 5, and that is true, right? So this is the condition. So what is the case for equality? Well, let's see it. So for equality, again xy will be greater than equal to 0, right? For equality. Why? First case was this only, and the second one, let's take x is equal to negative 3 and y is equal to negative 2. Then negative 3 plus 2 mod is equal to 1, and over here we will get 3 minus 2, which is also equal to 1. So for this, equality holds. So this implies that mod of x minus mod of y is equal to mod of x minus y. And if this expression is less than 0, then it would imply that this expression is less than mod x minus y always, right? So you should remember this, xy less than 0 implies mod of x minus mod y is always less than mod x minus y, correct? Okay, fine. So these are some of the basic properties which you should always remember while making calculations, right? So let me erase this and let's discuss a problem which is very commonly asked in your examinations, and that is very important also. So let's see it also. So let's take a question. Let's take mod x minus 1 plus mod x minus 2 is equal to 1. Let's take this example, right? And then we'll move to 3 also, to 3 modulus functions even. But for now, let's take this one, solution, right? So here we have to make 3 cases, right? One in which x is less than 1, and one in which x belongs to 1 to 2, and one in which x is greater than 2, right? So notice that if you take x greater than 2, right? Okay, you can take greater than equal to also, there is no harm in that. Okay, then in that case both will open with a positive sign, correct? Right? So it means that 2x, let me explain it, x minus 1 plus x minus 2, right? Okay, why I opened both of them with positive sign? Well, if x is greater than 2, then it means that mod, I mean then it means that x minus 1 will always greater than equal to 1, and x minus 2 will always greater than equal to 0. So it means that the mod will open with positive sign over here also and over here also, since this is equivalent to saying x minus 1 is greater than equal to 0 also, is greater than 0 we can say, right? Correct. Of course they both are not equivalent, because between 1 and 0 we have infinite numbers, right? But still, to explain it, I'm writing like this. Let me erase this, right? It is equal to 1, so we have 2x minus 3 is equal to, so we have x is equal to 2. So x is greater than equal to 2 and x is equal to, it belongs to this domain. It means that x is equal to is one of the solutions, and of course when you substitute it, here is 0 and here 1, so you get 1 is equal to 1, so x is equal to is a solution, right? Okay, now let's take the case in which x belongs from 1 to 2, right? Okay, notice that they both are open braces, not closed, right? So 1 and 2 are not included in that, right? Okay, So in this interval, x minus 1 will belong to 0 to 1, correct? And of course it is a positive quantity, right? But x minus 2 belongs to 0, sorry, negative 1 to 0, correct? Right? So basically it is a negative value, so it will open with a negative sign, right? So x minus y opens as it is, plus, but plus will become minus x minus 2 is equal to 1, and it means that 1 is equal to 1, right? Correct? Just solve it. And it implies that it is true for all values of x. This means for all x belonging to 1 comma 2. So this is a solution, right? Correct? Okay. Now if x is less than this quantity, if x is less than equal to 1, right? This is the third case, this is the first case, this is the second case, and this is the third case, right? Fine. We have negative of x minus 1 minus negative of this quantity is equal to 1. Of course, if you have taken less than this quantity, then it means that this will also open with a negative sign, this will also open with a negative sign, correct? Okay. So in this you have negative 2x, and this will become plus 3 is equal to 1, right? So x is equal to 1 in this case, right? And it belongs to this domain also. So it means that x belongs to 1 union 1 to 2 union 2, right? And it is equivalent to saying x belongs to closed 1 to 2, right? This is the solution, right? 1 and 2 are included in this case, right? I could have made this problem a bit interesting if I would have said greater than equal to instead of equality, then it would become more interesting. So let's see this also. So let's assume this case now. So again we are going to make three cases like that. X greater than equal to 2, right? This is our first case. So x minus 1 plus x minus 2 greater than equal to 1. So 2x minus 3 greater than equal to 1. So x is greater than equal to 2, right? So it means for all values of x greater than equal to 2, this is true, right? Because this and this are exactly same, right? So it means that x greater than 2 intersection x greater than 2 is basically equal to x greater than 2, right? So x belongs to 2 to infinity is one solution in this case, right? Now let's see other solutions, right? X belongs to 1 to 2, right? Similar to that case. So x minus y minus x minus 2. Okay, let's change this value a bit. Let's take it suppose 3 to make it more interesting. So this was 3, this was 3. So from this you get it is greater than 3, right? Greater than 3. Now notice this. Now let's see this, right? So this was this condition and this was this condition, right? Okay, I changed it from 1 to 3 to make the calculations bit interesting, right? Okay, so what is this condition? This is 2 and this is 3. So this region is this one and this region is this one. So what is common region? This region is common. So it becomes x belongs to 3 to infinity is one solution in this case. Now let's take this one. Okay, greater than or equal to 3, right? Correct. So 1 is greater than or equal to 3, which is false for every value of x since it is independent of x, right? So it means that x belongs to 1 to 2 is not a solution, right? Clearly not a solution, right? Okay. Now let's take it for x less than or equal to 1, correct? Okay. So in this case, it will open with a negative sign, right? As previously said, right? Correct? Are you understanding or not how I am opening these mod, right? See, I explained it already. If you take x minus 1, it will be less than 0. So the mod will open with a negative sign, right? Since it is less than 0, if you remember the property of mod, right, from starting, and mod of and x minus 2 will be less than or equal to negative 1, and which of course is less than 0, right? So of course it will also open with a negative sign in this case, right? Okay. So negative 2x plus 3, this and this gets cancelled, so x is less than equal to 0, right? So x less than 1, less than equal to 1, and x less than equal to 0, and when you take intersection you get what? You will get x belongs to negative infinity to 0, right? Now notice this and this, they both are solutions, so the solution becomes negative infinity to 0 union 3 to infinity. Correct? Understood or not, right? That is how you check for conditions, right? So if you want to check, you can suppose you assume it as 0, so 1 plus, or 0 is true, you take negative 1, negative 1, negative 1, it becomes 2, negative 1, and this of course it becomes positive quantity, right? And suppose you take 4 over here, so 4, of course it will be greater than 3, right? So it means this solution is true, it is correct, right? And of course if there's any ambiguity, then please do let me know in the comment section, because I'm making questions right now only, right? I have not seen it from any book, right? So there's a chance that I would have taken some wrong questions, so please, if you see any ambiguity in this, then please do let me know in the comment section, right? I'm solving it right now only, so I don't know that whether I'm making any calculation mistake or not. So please, if you see any problem in my calculation or any problem question, just point it and let me know in the comment section. I will correct it or make another video on its solution, right? So let's take another case in this, right? So this is another question, but before that, let me tell you one thing. I forgot to tell that time that mod of x, if it is less than a, then it implies that x belongs to negative a to a, right? Correct? Okay. Why? Because this negative a, this a, so this is the region we are talking about, right? Okay. So whatever value you take in this range, in this interval, whenever you take its mod, it will of course lie between 0 and a, right? Correct? Yeah, that's fine. So suppose if you take mod of x less than equal to 2, then in that case x belongs to negative 2 to 2, correct? Fine. Okay. Again, it will open with the x less than, if x is greater than 0, greater than equal to 0, and it will open with x negative x if x is less than 0, which means that x is greater than negative a, right? So x greater than negative a and x less than a implies x belongs to negative a to a, right? You have to take the intersection of both of them, right or not, right? Okay. So this is also a famous condition, you should remember it, right? And of course they are a bit obvious, so you should be well acquainted with it. Okay, so let's take this problem also. So I directly took some hard problem in this case, like I did not use equality directly, I used inequality over here to explain the problem, because if equality is there, you again apply those conditions and you will get single answers, right? And you have to just check for the limits, the condition, the cases that the value of x does lie in that or not, right? I have to tell one thing, that suppose you got x is equal to 1, but your case is stated that x is greater than equal to 2, right? And in that case you got x is equal to 1. So will you consider this or not? Well, if you assume x greater than equal to 2, then how can you assume that x can be 1, right? Because if x is equal to 1, then this implies that this condition is not satisfied. But you made your case only when you assume that x greater than equal to 2. So it means that this is never possible, right? So remember this, if you get first of all, your work is to check for that whether the value you got is lying in the domain or not, which you assumed for that case, or right, understanding or not? Why? Because of course if it won't lie in the domain, then how can you check for it, right? And suppose if you get x less than equal to 2, in this case suppose you get x less than equal to 2, then in that case also there will be no solution since x was greater than equal to 2, right? But if you got x less than equal to 2, then in that case there will be only one solution, that x is equal to 2, right? Understood or not? Right? Okay, because x is greater than equal to and x is less than equal to 2, which means that what is the common part? It is just 2, right? So that is why 2 will be the answer in that case, right? So these are the things which you should remember. These are very minor details, but it always makes lots of mistake in examinations. You should remember this one. Okay. So what is the greatest value which you will get in this? It will be x greater than equal to 3, right? Correct. So they all will open with a positive sign, right? So x, x and x, it becomes 3x minus 6. It is less than equal to 4. Correct. Right. Correct or not? Yeah. So it means that 3x is less than equal to 10. So x is less than equal to 10 by 3. Correct. Okay. Now notice that x is less than equal to 10 by 3 and x is greater than equal to 3. Then what is the common region between them? This is the intersection. Well, if you know, you can directly do it. If you don't know, then do it like this. This is 10 by 3. It is 3.33, something like this. Okay. So only these values are allowed. Why? Because one allows like this and the other allows like this, right? So this region is only common. So you get x belongs to 3 to 10 by 3. Correct? Yeah. That is what I was saying. You have to check whether those values are lying in the domain or not, right? So this could have been a complete solution, but you had another condition also to check. The condition which you use to make a case, right? So that is the most important thing which you have to check. And of course, in intersections, you have to take the common region only. So of course, other region will get eliminated, right? Just you have to think with lots of concentration that what values you have to choose, right? Okay. And again, I'm saying that there's a chance that I make calculation errors. So please let me know in the comment section if you see any, but I will try that I don't make any, right? So now what is the case? Let's assume that x belongs to, suppose we can assume it as let's take 2 to 3, correct? Let's assume it. Then in this case, this will open with a negative sign, this will open with a positive, and this will also open with a positive, right? Again, you can use like x minus 1 and x minus 2 in this to check for it. Okay. So x and x, it will become 2x minus 3, and that will open with a negative sign. So plus 3 minus x is less than this quantity. This and this gets cancelled. So x less than equal to 4, right? Now x less than equal to 4 and this expression. So x belongs to 2 to 3, right? This is a solution, right? Correct? Okay. Now you can check for this and this quantity, right? X belongs to 1 to 2. Why I used a closed braces over here? Because we did not check for 2 over here, right? So we have to check for 2 also, right? Either you can directly put the value at 2 and check, or you can directly make this case to understand the problem, right? Okay. So if you put 2 over here, you will get 1 plus 0 plus 1. So of course, at 2, it is satisfying. But of course, let's put 2 over here only in closed braces. It is more fun to do like that. So this will open with negative, this will open with negative, and this will open with positive. X minus 1 minus x minus, this will become 2x minus 5 less than equal to 4. Correct? Okay. Correct or not? Right? So you get x minus 1 minus 2x plus 5 less than equal to 4. So it means that negative x is less than equal to 0. Correct? So x is greater than equal to 0. It implies that x belongs to 1 to 2 is completely a solution since their intersection is giving this value, right? Correct? Okay. Now x less than equal to 1. So all will open with a negative sign, so it will become 3x minus 6 greater than equal to 4. Correct? Did you understood how? This will open with negative, this will open with negative, this will open with negative. If all are getting opened with negative sign, then I just multiplied both sides by negative 1, right? This less than 4, so correct, right? When we multiply both sides by a negative quantity, sorry, it will be a negative 4. Yeah, that is the reason you all must have got confused. It will become this. Correct? Correct or not? Yeah, it is correct. That is why, and you can solve it. 3x less than equal to 2x greater than 2 by 3. It means that when you take the intersection, x belongs to 2 by 3 to 1, right? So what is the complete solution? The complete solution is this expression. X belongs to 2 by 3 to 1 union 1 to 2 union 1 to close to, sorry, right? Union 2 to 3 union, or you can take it like this also, this union union 2 to 3, to avoid this ambiguity that here we have a closed and here we have a open and here we have a closed, so I wrote it like this only, right? Okay. Union 3 again, union 3 to 10 by 3 close bracket. Again, to remove the ambiguity, I just did like this. Okay, so this is your complete answer, right? And of course, if there is any calculation error, please do let me know, right? So this was a very basic lecture about modulus function, and I hope so that this will give you a brief idea that how the things are happening in the modulus function. And yeah, I did not use graph over here to solve such kind of inequalities or problems, because many times you get confused with the graph. So if you want to know about graphs, how we solve it, then please do let me in the comment section. I will make a video on that also. So till then, bye bye, take care, and please do like, share, subscribe my channel, and all the best.